Welcome to Module 3 of SARI Facility Design course. This specific module is focused on how to repurpose existing building into a SARI treatment center. By the end of this lecture, you will be able to assess and evaluate available existing structure, identify key and essential structural elements, and describe how to adapt an existing building into a SARI treatment center. The lecture is organized in two different sections for easy understanding. Section 3A on basic design principle and Section 3B on the existing building selection process. Welcome to Module 3A on basic design principle. There are some essential features a SARI treatment center must have: access and flow, space allocation for mixed area and restrict area for staff only, proximities between these different areas, dimension and distances, ventilation and light, and material. However, before starting any other consideration, we should decide the expected bed capacity, as it's the main parameter leading the building selection process. The first essential structural element is the patient's entrance. It should include patient reception, waiting room with dedicated toilet, triage, both for patients and staff, and a sampling room. On the staff side of the triage, there should be the staff area, including entrance, changing room, toilets, offices, logistic area, and all support service such as laundry, data management, and pharmacy. Third element is the patient's area with different wards for mild, moderate, severe, and critical patients. The three elements should allow a proper flow, both for patients and staff. Here we can see the patient flow, moving from entrance to the waiting room, passing through the triage, sampling, which is not mandatory but according to medical consideration, and finally ward, where patients can move back and forward according to medical condition. Staff flow should be controlled as well, two different entrances for staff and goods, and the possibility to access reception, triage, and patients directly from the staff area. Here, how space allocation should work. Two main areas, one mix for staff and patients in orange, and one only for staff in green. This reduces the risk of infection for healthcare workers and allows a rationalized use of PPE, leading to a significant reduction in consumption and providing a safe place for staff to rest. Some services require specific characteristics, such as being close to each other with a determinate spatial arrangement in order to assure a proper flow both for patients and staff. A clear example is the patient's entrance, composed of the reception, waiting room, and triage. These spaces have to be next to each other in order to allow a proper flow and functioning. While assessing the surface available, we should consider that some service has specific special requirements. The waiting room, screening, triage, and mild-moderate wards, for instance, should be spacious enough to ensure 2-meter distance in between patients. This distance can be reduced with the use of screens and transparent surfaces. 2 meters of distance is also recommended in between suspect cases of a quarting approach. Note that the recommended spatial distance for infection prevention and control measure is 1 meter. However, in order to facilitate access and movement of healthcare workers, 2-meter distance is advised. Severe and critical cases may need to be transported to their respective ward within hospital beds. Once possible location for critical and severe wards has been identified, check the pathway heading to this area to see if they are accessible with the hospital beds. If pathways are not wide enough, check if the area are accessible with stretcher. Here, the minimum dimension requirement for hospital bed and stretcher. Check if the door and corridor are wide enough to allow passage. Self-contained room for severe and critical patients should be spacious enough to contain all the needed biomedical devices and for medical staff to stay at the bedside without any issues. Recommended surface is at least 9.6 square meters per room. Ventilation is a key component for IPC in a SARI treatment center. Different types of ventilation are required according to specific service and wards. Natural ventilation with a minimum flow rate of 60 liters per second per patient should be assured for the service in violet, waiting room, triage, mild and moderate wards. Other services, such as severe and critical patients ward, should have hybrid ventilation with a top-down airflow and a minimum flow rate of 160 liters per second per patient. Some buildings, especially high-density index facilities such as sport hall, healthcare facility, office and school, may already have mechanical ventilation in place. If already available, assess the flow rate, the flow direction and how the exhausted air is treated or diluted. Finishes and furniture as well should meet specific technical characteristics to allow correct IPC measure. They should be cleanable, material easy cleanable and resistant to repeat cleaning, easy to maintain and repair, resistant to microbial growth, non-porous and seamless. Welcome to Module 3B, focus on existing building selection process. Now that we know what we should consider, let's see how to identify an existing building according to structural layout and surface. As already said, expected bed capacity should be the leading factor. This graphic provides indicative meter square per total bed capacity and meter square per patient. For instance, for a 50 beds capacity center, we should consider a building with a surface around 2,000–2,500 meters square, while for 2,000 bed capacity, we should consider surfaces around 8,000 meters square. These figures are an indicative estimation based on architectural standard and previous field experience with other infectious diseases. To facilitate the building selection process, we try to categorize all the different types of building into 3 categories. Building with a vertical distribution, such as accommodation facility, hotel, student accommodation, school and offices. Building with a horizontal distribution such as school and offices, and big open space such as sport hall and trade fair pavilion. Vertical distribution buildings such as hospital, residential complex, offices or school are usually characterized by a similar layout reproduced on all floor with support services gathered at ground floor. The ground floor could have a hall with a reception, big room for conferences, canteen or a meeting. The other floor have one side or double side room with a central corridor. Bathroom could be individual or public. Here an example on how a vertical building such as an hotel can be repurposed into a site treatment center. On the left side, how the existing space are currently allocated, like hall, canteen, conference room. And here, how space can be repurposed with the hall becoming patient reception and waiting room, the canteen turned into staff area and warehouse. The color represents the different area and patient's categorization by severity. Horizontal distribution buildings, such as residential complex, offices and school, usually are characterized by a central hall, office nearby and one or more corridor. Usually corridors start from the hall. They could also host big area, open space, such as gymnasium or conference room and libraries. An example can be a school. Here, how a school can be repurposed, assuring flow and area delimitation. Open space buildings include fair trade pavilion and sport halls, such as basketball and volley courts. Usually present wide halls, office, public bathroom, and big open and empty space, such as the playfield. Due to their layout, open space building could be easily adapted to temporarily isolate patients with a cohorting approach, such as community facility. Big fair trade pavilion, due to their dimension, are able to host the whole site treatment center. A basketball court can be easily repurposed into a site treatment center with cohorting approach. Here, the example with the basketball court turned into a patient's ward and all the other space repurposed into supportive service. This table provides an overview on area-specific minimum requirement and can be used to assess the existing building once identified. Now, imagine we identify the building. The next step will be to gather all information and technical documents needed to launch the design process. Be sure to have all the technical drawing, plans of the existing building. Be sure to have plans and technical specification for ventilation system, plumbing and electrical system. Then we can start the design phases. Here resume in 5 steps. Identify existing access and building distribution system. Try to find out 2 different main access, one for the patients and one for the staff. Considering the dimension, proximity and flow. Check if electrical ventilation and plumbing system and waste management are appropriate for a site treatment center. Check if the emergency pathway and doors are correct also according to the new layout, and decide which kind of intervention you need to adapt the existing building to a site treatment center requirement. Using the building technical drawing, we should start identifying existing access and building distribution system. Try to find out 2 different main access, one for patients and one for staff, as shown in this picture. Considering dimension, proximity and flow, try to assign specific COVID-19 area to the existing area. Check if electrical, ventilation, plumbing system and waste management are appropriate for the repurposing. Check if the emergency pathway and doors are still accessible according to the new layout. Finally, draft the intervention to repurpose the existing building. This is the conclusion of the course, and I want to thank you for attending the different modules. If you have any question or you want to share your proposal for input and feedback, you can contact us at oslhealthtech@who.int.